Chapter 2. Study of Gas Laws. Introduction. Gases have certain properties which differentiate them from solids and liquids. The three states of matter are solids, liquids, and gases. Gases differ from solids and liquids in the following ways. 1. Gases do not have a definite shape or volume, as in the case of solids and liquids. Liquids have no definite shape. 2. The distance between the molecules is much larger in case of gases, comparatively less in liquids, and almost negligible in solids. 3. The force of attraction between the molecules is negligible in case of gases, comparatively more in liquids, and maximum in case of solids. 4. Molecules of a gas move in straight lines, undergo random collision with other molecules, and occupy the complete space available in the container, unlike solids and liquids. Behavior and characteristic properties of gases. Behavior and properties of gases can be explained on the basis of kinetic theory. First, let's see the behavior and properties of gases. 1. No definite shape or volume. Gases occupy all the available space, that is, the shape and volume of the container in which they are filled. Let us now see the explanation on basis of kinetic theory. No definite shape or volume. Molecules in a gas are far apart, and the force of attraction between the gas molecules is very weak. Molecules are in continuous motion in the entire available space, and their movement is restricted only by the walls of the container. 2. The second behavior and property of gases is high compressibility. The volume of a given mass of gas can be easily compressed to a much smaller volume by increasing the pressure upon it. Let us see the explanation on basis of kinetic theory. High compressibility. Volume of particles negligible compared to intermolecular distance, hence can be compressed, that is brought closer to each other. Third behavior and property of gases. Exert pressure in all directions. Gases, unlike solids and liquids, which exert pressure only partially downwards, exert equal and uniform pressure on the walls of the container. Explanation on basis of kinetic theory. Exert pressure in all directions. Impact of gas molecules with high velocity causes pressure to be exerted on the walls. The same number of molecules strikes a given area on the wall in unit time. Fourth behavior and property of gases. Have low densities. Gases have much lower densities compared to solids or liquids. Under ordinary pressure, conversion of a given mass of solid or liquid to a gas causes a much greater increase in volume than the original. Hence, the density of gases is very low compared to solids and liquids. Explanation on the basis of kinetic theory. Have low densities. The intermolecular distance between the molecules of gases is very large. Hence, the number of molecules per unit volume of a gas is much lower compared to solids and liquids. Gases, therefore, have very low densities. And the fifth behavior and property of gases, diffusibility or miscibility. Gases diffuse readily, and when kept in contact with one another, combine completely, forming a homogeneous mixture. Let us see the explanation on basis of kinetic theory. Diffusibility or miscibility. The space between the molecules of gases is very large since the intermolecular distance between the gas molecules is large. Hence, the gas molecules have a tendency of mixing with other gas molecules, their speed of movement depending on the mass and temperature of the gas. Gas laws. Gas laws are certain rules which a gas follows when subjected to a change in temperature, pressure, and volume. The effect of change of any one of the above parameters affects the other two parameters. For example, volume of a gas undergoes a significant change if its pressure or temperature is slightly changed. The parameters are described in the table shown below. Temperature, pressure, and volume. Temperature. It is an indicator of the average kinetic energy possessed by a molecule. Kinetic energy increases with an increase in the temperature. Units of temperature. Celsius temperature, which equals degree C. Kelvin temperature, which equals K. K is equal to degree C plus 273. Now let's see pressure. What is pressure? Average force exerted by bombardment of gas molecules on the walls of a container per unit area of the container, or the ratio of the force exerted on the walls to the total area of the container wall. Unit is atmospheres. Centimeter Hg is to millimeter Hg. Torricelli. 1 atmosphere is equal to 76 centimeter of Hg, which equals 760 millimeter of Hg. 1 millimeter of Hg is equal to 1 torr. Now, volume. Gases have indefinite expandability and occupy the volume of the container. Volume of the gas is the space occupied by a fixed mass of gas. 1 liter is equal to 1 decimeter cube, which equals 1000 centimeter cube. 1 decimeter cube is equal to 1000 centimeter cube, which equals 1000 milliliter. 1 centimeter cube is equal to 1 milliliter. ml is equal to milliliter. L is equal to liter. cc is equal to cubic centimeter. dm cube is equal to cubic decimeter.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें.
Relation between pressure and volume of a gas when temperature is kept constant. 1. Pressure is increased. When the temperature of a fixed mass of gas is kept constant and the pressure is increased systematically, the volume correspondingly decreases. A gas X occupies 500 milliliter when the pressure is 2 atmospheres and 250 milliliter when the pressure is increased to 4 atmospheres. 2. Pressure is decreased. When the temperature of a fixed mass of gas is kept constant and the pressure is decreased systematically, the volume correspondingly increases. If the pressure is decreased to 1 atmosphere, the volume of the gas is 1000 milliliter. Let us see different experiments, experiment numbers, pressure in atmospheres, and volume in milliliters. Experiment 1, pressure is 2, volume is 500 milliliter. Experiment 2, pressure 1 atmosphere, volume 1000. Experiment 3, pressure is 4, volume 250 milliliters. Relation between temperature and volume of a gas when pressure is kept constant. 1. Temperature increased. When the pressure of a fixed mass of gas is kept constant and the temperature of the gas is increased systematically, the volume correspondingly increases. A gas Y occupies 200 milliliter when the temperature is 400 Kelvin. If it is heated to 600 Kelvin, its volume is increased to 300 milliliters. 2. Temperature decreased. When the pressure of a fixed mass of gas is kept constant and the temperature of the gas is decreased slowly, the volume correspondingly decreases. The gas Y occupies 100 milliliter when the temperature is decreased to 200 Kelvin. Experiment numbers, temperature in Kelvin and volume in milliliters. Experiment number 1, temperature is 400 Kelvin, volume is 200 milliliter. Experiment number 2, temperature 600 Kelvin, volume 300 milliliter. Experiment 3, temperature 200 Kelvin, volume 100 milliliter. Boyle's law. Robert Boyle studied the relation between pressure of a gas and its volume. Robert Boyle found that at constant temperature, the volume of a fixed mass of gas goes on decreasing as the pressure is increased. On doubling the pressure, the volume decreases by half. The behavior was generalized and was named Boyle's law after Robert Boyle. Thus, Boyle's law states that temperature remaining constant, the volume of a given mass of dry gas is inversely proportional to its pressure. V is inversely proportional to P, where T is constant. 1. Let a particular mass of gas occupy volume equal to V, pressure equal to P, at constant temperature equal to T. According to Boyle's law, V is inversely proportional to P, T is constant. Therefore, V is equal to K into 1 upon P, K is a constant. Therefore, PV is equal to K is equal to constant. 2. If the particular mass of gas occupies, first, volume V1 at pressure at P1, second, volume V2 at pressure P2, according to Boyle's law, P1 V1 is equal to P2 V2 is equal to K, where T is equal to constant. This is Boyle's law equation. Boyle's law is also defined as temperature remaining constant, the product of the volume and pressure of a given mass of a dry gas is constant. Validity of Boyle's law. Let's consider an experimental data to illustrate validity of Boyle's law for a specific gas at constant temperature. The table shows experiment numbers, pressure P in atmospheres, volume V in milliliters, pressure into volume, that is P into V. Experiment 1, P is 1, V is 1000, P into V 1000. Experiment 2, P is 2, V is 500, P into V 1000. Experiment 3, P is 4 atmospheres, V is 250 milliliters, P into V is equal to 1000. Conclusion: pressure into volume, that is P into V, has a constant value.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें.
Problems based on Boyle's law. Problem 1. A gas is allowed to expand at a constant temperature from an initial volume of 300 milliliter to a final volume of 1800 milliliters. At the end of the expansion, the pressure of the gas was found to be 1 atmosphere. What was the initial pressure of the gas? Solution: V1 is equal to initial volume of the gas, which equals 300 milliliter. V2 is equal to final volume of the gas, which equals 1800 milliliters. What is P1, the initial pressure of the gas in atmospheres? P2 is equal to final pressure of the gas, which equals 1 atmosphere. By Boyle's law, P1 V1 is equal to P2 V2. Substituting the values, x into 300 is equal to 1 into 1800. Therefore, x is equal to 1800 upon 300, which equals 6 atmospheres. Therefore, the initial pressure of the gas is 6 atmospheres. Problem 2. A certain mass of chlorine gas occupies 750 centimeter cube at a certain pressure. When the pressure was changed to 2.5 atmospheres, it occupied 1500 centimeter cube. What was the initial pressure if the temperature was kept constant during the complete operation? Solution: V1 is equal to initial volume of the gas, which equals 750 centimeter cube. V2 is equal to final volume of the gas, which equals 1500 centimeter cube. What is P1, the initial pressure of the gas in atmospheres? P2 is equal to final pressure of the gas, which equals 2.5 atmospheres. By Boyle's law, P1 V1 is equal to P2 V2. Substituting the values, x into 750 is equal to 2.5 into 1500. Therefore, x is equal to 2.5 into 1500 upon 750, which equals 5 atmospheres. Therefore, the initial pressure of the gas is 5 atmospheres. Problem 3. A certain volume of the gas was found to be at a pressure of 1200 millimeter of mercury. When the pressure was decreased by 500 millimeter, the gas occupied a volume of 2400 centimeter cube. Calculate the initial volume occupied by the gas if the change was done at a constant temperature. Solution: what is V1, the initial volume of the gas in centimeter cube? V2 is equal to final volume of the gas is equal to 2400 centimeter cube. When P1 is equal to initial pressure of the gas, which is equal to 1200 millimeter, and P2 is equal to final pressure of the gas equals 700 millimeter. By Boyle's law, P1 V1 is equal to P2 V2. Substituting the values, 1200 into x is equal to 700 into 2400. Therefore, x is equal to 700 into 2400 upon 1200 is equal to 1400 centimeter cube. Therefore, the initial volume occupied by the gas is 1400 centimeter cube. Charles' law. Jacques Charles studied relation between temperature of a gas and its volume. Jacques Charles studied the temperature-volume relation of gases and found experimentally that for a fixed mass of gas at constant pressure, the volume expands or contracts that is, increases or decreases by 1 upon 273 of its volume at 0 degrees Celsius for every degree Celsius rise or fall in temperature. The behavior was generalized and was named Charles' law. Thus, Charles' law states that pressure remaining constant, the volume of a given mass of dry gas increases or decreases by 1 upon 273 of its original volume at 0 degrees Celsius for each degree centigrade rise or fall in temperature.
अगर आप अपने सिलेबस के सारे चैप्टर्स इस फॉर्मेट में देखना चाहते हैं तो हमें डिस्क्रिप्शन में दिए गए नंबर पर कॉल करें। ऐसे ही और एजुकेशनल वीडियोस देखने के लिए हमारे चैनल होम रिवाइज को सब्सक्राइब करें।